Learning objectives: to identify excluded values and to identify and use asymptotes to graph rational functions. Here is our first learning objective: to identify excluded values. Let's take a look at what we need to do in order to find the excluded values of rational functions. Here is the definition of rational function, which we have already discussed. Now let's see the general form of parent function. The parent function of rational functions is of the form f of x equals 1 over x where x not equals 0. What type of graph we get for rational functions? The graphs of rational functions is known as hyperbola. What about domain and range? The domain is the set of all values of x such that x not equals 0, and range is the set of all values of y such that y not equals 0. Why did we write x not equals 0 and y not equals 0 here? Look at this graph. Here, the hyperbola is not passing through the origin 0, 0. That means this graph is undefined for the values of x equals 0 and y equals 0. Now let's see in detail what are excluded values. Since division by 0 is undefined, any value of the variable that results in a denominator of 0 in a rational function is excluded from the domain of the function. These are called excluded value for the rational function. That means when we have a variable in the denominator, we have to make sure that the variable is not 0 because the division by 0 is undefined. Now let's look at a few examples on how to find the excluded values. Here is our first example. Y equals negative 2 over x. As you know, the denominator cannot be equal to 0, so the excluded value is x equals 0. Let's try another example. Y equals 2 over x plus 1. First, let us see on what value of x this denominator becomes 0. So we need to equate the denominator terms to 0. That is x plus 1 equals 0, which implies x equals minus 1. That means when x is minus 1, then we get minus 1 plus 1. The denominator is 0, which is undefined. So we can conclude that the excluded value in this case is x equals minus 1. It is your turn now. Please pause the video here and resume when you have your answer. Alright, here are the answers. Well, now let's consider an example from real life and see how to graph it. Here is the question. If there are X people in the basket of a hot air balloon, the function y equals 20 over x represents the number of square meters y per person. Graph this function. As you know, to graph a function, first we have to create a table containing x and y values. Here is the table. Here I have considered some values which are factors of 20 to avoid the decimal values from y. You can consider any value for x, but for convenience it is always better to consider the factors of 20 so that the decimal will not be present in the values of y. The next step is to plot these values on the graph. Here is the graph we obtained from the following values. It is your turn now. Here is the question. Please pause the video here and resume when you have your answer. Alright, let's look at the answer. Here is the table and the corresponding graph.
Now before we continue, please don't forget to like the video and subscribe to our channel. As a reminder, we offer private and group online math lessons on Zoom, where we cover all UAE National Curricula, American and British curriculums. We also have the best MSAT math test preparation course with a 50% discount for groups. The first session is always free. So if you are interested in a free lesson, click the link in the description below. To book a lesson you can always send us a direct message on Instagram at Mr. Mathematics. Okay, with that said, let's get back to our lesson.
Now let's move on to the second learning objective. That is, to identify and use asymptotes to graph rational functions. What are the key concepts here? What is an asymptote? An asymptote is a line that a curve approaches as it heads towards infinity. That means a rational function in the form y equals a over x minus b plus c, where a not equals 0, has a vertical asymptote at the x value that makes the denominator equal 0, that is, x equals b. It has a horizontal asymptote at y equals c. From this statement, we understand that a rational function will have vertical and horizontal asymptotes. When do we get a vertical asymptote? A vertical asymptote occurs at the x value that makes the denominator equal 0. Here, x minus b is the denominator, and when x equals b, the denominator will be 0. Therefore, the vertical asymptote occurs at x equals b. Similarly, as per the definition, the horizontal asymptote occurs at y equals c. So here is the horizontal asymptote. Now let's consider an example. Here y equals 1 over x minus 2 plus 1. How do we find its vertical and horizontal asymptotes? As you know, to get a vertical asymptote, we have to equate the denominator to 0. That is, x minus 2 equals 0 and we get x equals 2. That means the vertical asymptote occurs when x equals 2. Here is the vertical asymptote. Now let's see horizontal asymptote. How do we get the horizontal asymptote? A horizontal asymptote occurs at y equals c. What is c here in the question? Here c is 1. Therefore, the horizontal asymptote occurs at y equals 1. Moving on, in general, we can say that like logarithmic and exponential functions, rational functions also have asymptotes. The function f of x equals 1 over x has a vertical asymptote at x equals 0, that is the y-axis, and a horizontal asymptote at y equals 0, that is the x-axis. Now let's consider an example. Identify the asymptotes of following function. Then graph the function. Here is the question. Y equals 2 over x minus 4. In this question, we are asked to find the asymptotes of the given function and then graph the function. What are the steps? The first step is to identify and graph the asymptotes using dashed lines. How do we obtain these asymptotes? As we learned before, the vertical asymptote occurs at the value of x, which makes the denominator 0. Therefore, the vertical asymptote is x equals 0. Next is the horizontal asymptote. The horizontal asymptote occurs when y equals c. What is c here? Here c is negative 4. Therefore, horizontal asymptote is y equals negative 4. Next, we have to mark these asymptotes on the graph. Here is the graph. the vertical asymptote is the y-axis and the horizontal asymptote is y equals -4, that is the line parallel to the x-axis. The next step is to graph the function. To graph a function, first we have to make a table of values and then plot those points. Here I have taken some values for x which are factors of 2. You can see that I have considered both negative and positive values. Now we have to plot these points on the graph. Here is the required hyperbola. It is time for your turn now. Here are the questions. Please pause the video here and assume when you have your answer. Alright, let's check our answer. These are the answers. Now let's do a quick recap on the main concepts learned in the lesson. The main points are: for a rational function of the form f of x equals a over x minus h plus k, the graph is a hyperbola. There is a vertical asymptote at the line x equals h and the domain is set of all values of x such that x not equals h. And finally, there is a horizontal asymptote at the line y equals k and the range is set of all values of y such that y not equals k.